Which frame material is best? It's a rather subjective question, with no conclusive answer. Different frame materials have different properties that give them slightly different characteristics, but you simply cannot know how a bike will ride by its frame material. Different riders will have different preferences for what they want in a bike. And different frame builders will use varying levels of manipulation in tubing size, shape, and wall thickness to achieve different qualities. There are lots of myths and superstitions about frame materials, to be sure. You've heard all or most of them. Steel is real. Steel is heavy and dead. Aluminum rides too harsh. Aluminum is light and efficient. Carbon fiber is the best. Carbon fiber is too brittle. Titanium is noodly. Titanium is too stiff. Confused yet? You should be. The superstitions are just that, superstitions. Pay partial attention to a bike's frame material. Pay equal or greater attention to the quality of the tubing, the quality of the construction, and the way the bike rides. Don't get lost in hype about frame materials. That said, here's some hype. Steel. All steels have the same inherent stiffness and weight, regardless of strength. Reynolds 853 is no stiffer than 1010, mild steel. Adding a tiny bit of chromium and molybdenum makes it strong enough to butt or thin down in the middle, thus making it lighter. This alloy is usually referred to as chromoly. Most quality steel frames use a variation of chromoly. This principle of engineering frames to use less of a stronger, stiffer material is true for all frame materials. The materials themselves are not lighter, the way they are used allows the builder to use less material to build a stronger frame. At one time nearly all high-quality frames were steel chromoly. The recent development of very high-strength air-hardened steels, like Reynolds 853 or True Temper's ox platinum that gain rather than lose strength as they cool from welding, has made for frames that have a strength-to-weight ratio equal to titanium frames. The strength of any type of steel allows builders to engineer a certain amount of flex by using thinner tubes, which translates into what riders call a lively feel or springiness, something builders using aluminum can't do because when aluminum flexes it fatigues the metal, which ultimately can lead to failure. Steel frames are also relatively easy and cheap to repair, and the technology has been around for a long time. Cheaper steels are used in department store bicycles. Higher carbon content steel is easier to weld, and cheaper to manufacture into bike frames, although it yields much heavier frames. Aluminum. Introduced as a material for bicycle frames about 30 years ago, aluminum is now the most common material. It is less dense than steel, so it results in lighter frames. Because of its decreased density, it requires larger tube diameters to achieve enough strength for a bike frame. This creates a stereotypically harsher ride. Aluminum doesn't oxidize like steel, rust. Their lateral stiffness gives aluminum frames a quick feeling because the transfer of pedaling force is so immediate, but some complain that the same stiffness translates into a lack of vertical compliance, making for an unforgiving, harsh ride. This effect is ameliorated to some degree by the now common use of carbon fiber forks and suspension to soak up road shock. In order to guarantee strength, 6000 series aluminum must be very precisely thermally treated after being welded, then quenched, and then artificially aged. 7000 series is more forgiving. An aluminum frame can be made stiffer and lighter than steel because it is not nearly as dense. This is done by increasing a tube's diameter while maintaining the wall thickness, making a tube that is 8 times as stiff, but only twice the weight. This oversizing of tubing runs the risk of a beer can effect if the tube walls are thin too much. Aluminum's affordable lightness and stiffness make it the first choice these days for bikes with any kind of suspension. Titanium. Titanium has an excellent balance of properties for frame building, combining durability with lower weight. Titanium alloys are half as stiff as steel, but also half as dense. The strongest titanium alloys are comparable to the strongest steels. Stiff titanium frames need larger diameter tubes than comparable steel frames, but not as big as aluminum. Titanium is very corrosion resistant, and very light frames can be made stiff enough and strong enough for bigger riders. Most TI frames are the 3Al/2.5V alloy, 3% aluminum/2.5% vanadium, with the more difficult to use, 6Al/4V, 6% aluminum/4% vanadium, falling out of favor with most frame builders. As an element, titanium is one of the most plentiful elements in the world. But titanium frames are expensive not only because of the material costs, but because welding must be done meticulously to avoid contamination, and machining must be done precisely. Carbon fiber. Carbon fiber is a material made up of non-metallic graphite fiber cloth that is layered together with high-strength epoxy resin to form a matrix. Originally used in the aerospace industry, it can have a high strength-to-weight ratio, but it is quite expensive. Individual fibers of carbon are tremendously strong and stiff, but they are useless unless arranged in a strong pattern, and held together with a strong glue, usually epoxy. Unlike metals, in which strength and stiffness properties are nearly the same in all directions, carbon fiber composites can be tuned to orient the strength where it's needed, for instance, stiff laterally and compliant vertically. This makes carbon fiber the preferred material of choice for unconventional frames and shapes, as it can be molded and tuned more than any metal.